class, so we started the discussion for lesson 2 talking about the triangle sum theorem, which is that all the angles of the triangle add to 180. So since we've already talked about that, we're going to jump right into this example, which says classify each triangle by its sides and angles. So before we start, I think it's going to be important for us to find all these missing angles. So I'm going to highlight them. I think we will want to find all of these angles because it will help us solve the problem. So the first thing I am looking at is this right triangle that I'm tracing in blue. So this right triangle already has, we know it's a right triangle because it already has the 90-degree mark, and we already know that this angle down here is 70. So something we talked about yesterday is that the other two angles of the right triangle that aren't the right angle have to add to 90. Another way to think about this is that this angle is 90, this one is 70, and if we're looking for this angle, the three angles have to add to 180. So I could just do 90 plus 70, which is 160, and do 180 minus 160, which is 20. Now, another thing I could have done was realize, hey, these two angles have to add to 90 since this angle's already 90, and then we would figure out 90 minus 70 is 20. So there was a couple ways to find that angle. Now, the other thing I'm thinking about is that these three angles, the 40, this unknown angle, and the 90, create a straight line. So those three have to add to 180. So if I add 90 plus 40, I get 130. And if I do 180 minus 130, I get 50, which is going to be this angle right here. And I think probably the hardest one, well, there's a couple ways we could do this, is figuring out these two angles. This one here, this one there. But one thing I do know is that they need to be congruent. Why? Because this triangle is an isosceles triangle. If these sides are congruent, then these angles are congruent. So I think the easiest thing is looking at this. So since these add to 180, if I take 180 minus 115, I get 65, which means this angle is 65, and this angle is 65 since they have to be congruent. And let's just double check. If I did this correct, then these three angles should add to 180. 65 plus 65 plus 50 is 180. So I feel good about all these angle measures. Now, since that is done, I can classify all these triangles. Let's do it. Starting with NSE, I'm going to highlight it. NSE is this one. Let's look at the three angles, 25, 40, and 115. Since one of those is an obtuse angle, this is going to be an obtuse triangle. And something that we did not talk about, but it's important to note, is that if I do have three different angle measures, it means that all three sides are going to be different lengths. So if I have any matching angle measures, then those sides will be equal, the sides opposite of them. So since I have three different angle measures for NSE, it means I'm going to have three different side measures, which makes this a scalene triangle. Next triangle is ANE. ANE is this middle triangle, and that is an isosceles triangle because two of the sides are marked congruent. If you look at the angles, they are all acute angles. So this is an acute triangle, and it's isosceles because two of the sides are equal. AEK. AEK is this right triangle. So this is a right triangle. And all three angle measures are different, which means all three sides are different. Scalene. Now we're going to get a little bit harder. ASK. ASK is this whole thing. Okay, so one of the angles for this big triangle is 25, 70, and then I have to add these together. 65 plus 20 is 85 degrees, which means all three angles are acute So this is an acute triangle. And 85, 25, and 70 are all different angle measures, which means all the sides are going to be different, scalene. Finally, AES. Now this one, be careful. AES is this triangle. Okay, so one of the angles is 25. The other one is 65, but we have to add these two angles together, and 50 plus 40 is 90. So one of the angles is a right angle, which makes this a right triangle with three different angle measures, 25, 65, and 90, making it scalene. Okay. The other theorem that I want to quickly talk about, so we now know that all the angles add up to 180. We also know that if there's different angle measures, it means there's different side measures. And we also talked about how the two acute angles add to 90 in an equilateral triangle. All the angles add up or are 60 degrees each. So we have a lot going on. One thing we're going to add is called the exterior angle theorem. The exterior angle is if I were to draw a triangle and extend one of the sides like this. So it's you draw the triangle and it's like you're extending one of the sides. We're talking about this angle right here. Okay, so the angles formed by extending a side of the triangle forms a blank with its adjacent interior angle. It's a straight angle. Okay, so it forms a straight angle with its adjacent interior angle of the triangle. And so let's find the angle measures. If I know that angle 1 is 45 degrees and angle 4 is 125 degrees. Well, these two are a straight angle, which means they have to add to 180. So if I take 180 and I subtract 125, I get 55. Okay, so angle 3 is 55 degrees. How can I find angle 2? Well, I know two of the angles of the triangle, so I can do 45 plus 55, and since all triangles have to add to 180, I can subtract that sum from 180, making this one an 80-degree angle. Okay, so it's asking if we notice anything. It's going to be hard to notice based on one example. I don't even know if we would notice with two examples. In this one, this angle is 20. Angle 7 is 115. 180 minus 115 is 65. And to find angle 5, we can do 115 plus 20, the two interior angles, and then 180 minus that, 135, is 45. So here's what we wanted you to notice. If you add together these two angles, the ones that are not touching this exterior angle, let's see what happens. 80 plus 45 is 125. It's going to equal that exterior angle. Let's try it here. So if I add the two angles that do not touch this exterior angle, 45 plus 20 is 65. That's the exterior angles theorem. Okay, it's that the exterior angle of a triangle is always equal to the sum of the two non-adjacent angles. So if you want to pause the video and get that definition down, you can. And then one of my favorite theorems is the third angles theorem. If two angles of one triangle are congruent to two angles of another, then the third angles are congruent. Let me give you an example. If I know that this angle is congruent to, I'll switch it up on you, this angle, these are congruent, and that this angle is congruent to this angle, then what does it tell me about the third angles? It tells me they must be congruent. Let me show you why. Let's just say this was 30 degrees. And let's just say this one was, I don't know, 70 degrees. Those two add to 100. Okay, just keep that in mind. But with the congruent, if this green one is 70, so is this green one. And if the purple one is 30, so is this purple one. Okay, so those add to 100, which means this angle has to be 80, and so does this angle. So the third angles are always congruent if the first two other angles are. We're going to use all of these theorems to do some examples. Sammy will do some examples with you, but let me just quickly talk about maybe a couple of them. Number 2 is hard, but one thing I am noticing is that all of these are equal, which means it's an equilateral triangle, which also means it's equiangular. So all the angles add to 60, or all the angles are 60, they add to 180. And then since these form a straight line, I can do 180 minus 60 to get angle Y, which is 120 degrees. So X is 60 and Y is 120. Let's take a look at number 5. It says, in triangle ABC, the measure of angle A is 55 degrees, and the measure of angle B is 4 times larger than the measure of angle C. Let's draw this in. A, B, C. A is 55 degrees. Angle B is 4 times larger than the measure of angle C. So I'm going to write this. Angle B, when you see the word is, that's an equal sign. 4 times larger than angle C. Okay, So if I call angle C X, because I don't know what that is, then angle B is 4 times X. So that was a hard setup, but what I can do with this is add up all the angles, 4x plus 55, and set it equal to 180. So let's subtract over this 55. 180 minus 55 is 125. And I'm going to combine these x's together. So 5x equals 125. And I divide that 5 over to get 25 for x. So that one was tough. And I think we can, I'll let Sammy do 3 of them. I'll do number 6 with you guys just to speed it up. So if this angle is 90, this angle is 90, okay? So we have 4y plus 10 equals 90. Subtract the 10 over, 4y equals 80. Divide the 4. So y equals 20. Now, there's a couple different ways we can think about this. We do know this is a right angle, which we did learn that the other 2 angles have to add to 90, or you can think about it as the exterior angle theorem. The other 2 angles have to add to this one, which is 90. Either way you think about it, we're going to take these 2 other angles and set it equal to 90. Now, if you blank out and you forget to do that, you could always do this plus 90 equals 180. That's another way to solve. If you know all 3 angles equal 180, I mean, that's always true, then you can always just add all 3 angles to equal 180. Okay, so we're going to do 4x and x combines to 5x minus 5 equals 90. Add the 5, divide the 5. So 95 divided by 5 is 19. Solved for x and y. Okay, Sammy is going to do numbers 1, 3, and 4 with you, and then you guys can check the answers. So now that you guys have gone over some problems, let me just make sure that we're good to go. If you want to pause the video, here is the answer to number 1. We have an isosceles triangle, so these two angles are the same, making x 72. If I add these two together, I get 144, and then I take 180 minus 144, and that's 36. You could have set up an equation like 72 plus y equals 180 and still arrive at 36 degrees. So either way. Number 3 was really tough. So hopefully we got it, but if not, I think it's hard to figure out how you can get these. If you want to call these like a variable, you can. What I did was just, okay, all 3 of these angles have to add to 180. So let's subtract 54 from 180, and that leaves me with 126, and these need to be even. So they need to be exactly the same. So if I just take that leftover amount, 126 divided by 2, I get the angles, 63 degrees each. Then to get this angle, I just subtracted 63 from 180 because these form a straight line. And then I did the same thing. 180 minus that 117 is 63, and I got to split that in half to get the other 2 angles, 31.5. That one was tough. And then number 4, the exterior angles theorem. So I do add these 2 together, and I set it equal to this outside angle. When you solve, you get x equals 10. So I'm sure Sammy did a great job explaining that. And that is it. So thanks for tuning in, and go do your homework, which should be worksheet 2.